Hi everybody, I'm Roberto Polli from the Italian Digital Transformation Department. Let me tell you, I'm really excited to be here. This is my first EuroPython was 10 years ago, and after 2 years of stop, really I feel the emotion of being in the real life with you, and it's stunning. So let's start. Today we'll present you how to design schemas, API schemas that simplify API mashup and interoperability. I will start with the concept of controlled vocabularies and how to use them to create REST APIs that are based on a contract-first schema design. And finally, I will show how the National Data Catalog for Semantic Interoperability, which is a catalog that Italy is building, will support this kind of approach. To semantic web expert, this is not a rigorous talk presenting the semantic web. So Italy is a wonderful country, but it's very complex to create interoperable service. A cornerstone of our digital strategy is to uniform the APIs produced by thousands of public agencies, and all those APIs should be semantically interoperable. That means that the concepts that are used when developing them and designing them should be well designed. So, what's semantic? Semantic is the study of meaning. And let's see those two messages. Here I have two ambiguous API messages. If an agency sent to another name made in this way, okay, but is it a full name? Is it a given name? Is it a double name of a person? And in the other message, okay, I told you the income of Fabiano Romildo, but which is the currency? It is not possible to mesh up APIs with different formats and semantics. So which is the solution? The solutions are vocabularies. Controlled vocabularies are a computer science tool that uses URI for disambiguating terms. So every term is identified by a URI. I've got a prefix that identifies the vocabulary name. I've got a term, in this case it's a dog, and I've got a definition. In this case, this definition is expressed in natural language. There is this RDFS comment that tells it's natural language. The dog is a four-legged animal. Very easy. So vocabularies contains collection of terms and define concept and relationship of specific domains, for example, for healthcare, for finance, for personal information. And the core point is that they are validated by a designated authority that is not necessarily a public authority. For example, you can define your own vocabularies, you reserve a URI for it, and you define your terms for creating your schemas, and they are formally described using the turtle media type or their JSON counterpart, that is JSON for linked data. Those formats are equivalent. You can pass from turtle to JSON, LD, and back. And complex vocabularies are called ontologies. This is a very wordy term, while simple list of terms are called, code lists. There are other kinds of vocabularies that have different terms, but that is not the topic of this, this talk. So we want to define a vocabulary. We want to define the concept around person, and since everything in a vocabulary is a URI, I want to make it shorter. So I use prefixes instead of reading long URIs. And I will start defining terms using sentences, like in natural language. Every sentence is made of a subject, a predicate, an object, and clearly a final full stop. So, what is a person? A person in natural language, RDF's comment, is a natural person. For example, not a company. This is important. A given name is the given name of a person. Anna, very simple. What is a family? Well, this is not very easy because, for example, in the Italian core person vocabulary, a family, a registered family, is a group of people tied together according to a specific law. Beware, for the income vocabulary, family may have a different meaning according to a different law. And another example, I have another term. One term is child of. And this is defined in natural language, the child-parent relation. And this term is defined by two sentences. The one is the definition in natural language. The second sentence says that is child of is a relation that applies to a person. Which person? Every person? No. The person of the Italian vocabulary I used before. So I can process vocabularies with Python. I can use the rdflib to load a vocabulary. Vocabularies are loaded into something that is named a graph. But why a graph? Because since every term can be connected to other terms via relations that can be predicated, you will end in something that is like a knowledge graph. So you have terms connected by relations. When I import this kind of file into a vocabulary graph, I can serialize it in other formats. For example, if I serialize it in JSON for linked data, I have an object with a context that are the list of namespaces, and the graph contains all the predicates, all the sentences, and in JSON, a term is converted in this kind of object. Every predicate is a keyword of the JSON object, and the original resource is identified by the ID. I can take this kind of object and find the original term. Another example of vocabulary, the European vocabulary for countries. It's a vocabulary with all the countries recognized by the European Union. And at first I define the prefixes, then I will define the Italy country. It's defined by 3 predicates. The terms can be localized. And I can have a shorter version of this country. It's semantically equivalent to the previous one. It's some syntactic sugar, but it's always 3 sentences, and I define France with localization in different languages. The nice thing about vocabularies is that they can contain more information than what you expected. For example, the European vocabularies for country contain reference about previous countries. For example, the Czech and the Slovak Republic replace the Czechoslovakia, and on the converts, Czechoslovakia is replaced by Czech Republic and Slovak Republic. So I've got an information with a lot of a vocabulary with a lot of information that can be useful. So how do I use it? Well, the first step is to load all those vocabularies into a graph databases. And then, for example, there is Virtuoso, there is Amazon Neptune, and I can query this kind of graph databases using the Sparkle protocol. How does Sparkle works? Well, I inserted predicates, I query with predicates. In this case, I'm asking, I want all subjects that are in the scheme of the European countries vocabulary. I want all the subjects that has a preference label that has a concept, and I want all the subjects that have an identifier that is something, and I want that all the concepts should be expressed in English, and then I retrieve, well, a table. So I insert knowledge. I retrieve knowledge. It's not just like creating an SQL database. You can try it with that QR code. But it's another approach, but it's very interesting. And then what you can do with that, for example, you can use those information to create data sets that have a very well semantic meaning. In this case, I see a person that is identified by an email, is described by 4 sentences, and each sentence uses predicates defined in the vocabulary we used before. Moreover, the birthplace references the European vocabulary for countries. This means that even if I just send a simple message, when I reference the European vocabulary for countries, this means that offline I can mesh up this kind of information with all the information that are contained in that vocabulary. So if I want to check if someone, for example, the birthplace was Czechoslovakia, and I don't know which are the countries where this person can, to which I have to ask his birth certificate. In the European vocabulary for countries, I will learn that Czechoslovakia has been replaced by Czech Republic and Slovak Republic, and I can file 2 requests for information, one to the Czech Republic and one to the Slovak Republic. This is just a simple example. So, another example, okay, when I write APIs that relies on the same vocabularies, I can mesh them up. And it's very easy because, for example, I have one API with fields in Italian, a different API, for example, from another country or a region in Italy that uses a different language. We have, for example, regions that or provinces where they use both different languages such as German and Italian. They are free, for example, to use pyld in German, because if using the context, I can map those different information, those different payloads to the same exact information. That is, citizen where the given name is Mario, and the citizenship is the Italian one. Another very nice thing that I can do with vocabularies is translation. For example, I can have vocabulary mappings that go from different countries, and I can then translate objects and send information to other countries. For example, imagine I want information, my birth certificate, to Finland or back. If I limit to the fields that are compatible to the European Union vocabulary, I can take my payload that has a nome proprio, secondo nome, cognome, and paese. It's Italian. I map it through the Italian vocabulary to a set of recognized Italian fields that map, 3 fields map exactly to fields of the European Union vocabulary. 1 field has no mapping, okay, it's the alternate name, and then I can convert in a payload that is understandable by every European country. I can then convert that payload in the Finnish vocabulary, and in that case, that payload can be processed by a Finnish public sector agency or whatever. There may be, for example, that some fields have maps that are not recognized by the European Union, that is by all the European Union countries, but they have mappings, bilateral mappings. But well, this is not important because this can work even in different sectors. For example, if I agree on a vocabulary on finance, I can make the very same logic and apply the very same logic to different domains. So one of the issues we have currently is that there is no standard to communicate this information in API schemas. Those information are used, conveyed in the API payload, and we are trying to work out a solution that is explained here. So the strategy is this one. The first, you should design your API schemas accurately with a contract-first approach. Every property should be associated with vocabulary terms from dictionaries, ontologies, codices. You should include examples to validate your design and test conversion between, like one we showed in previous slides. And then you need to communicate the semantic information to your consumer. The very simple way we found after a bit of scouting and after discussing with other folks in the API ecosystem is to provide a custom field in the JSON schema. And this is because we didn't want to overlap with other specification. Currently, there are a lot of custom solutions, and there are a lot of overlapping specification where people get and use different or the same properties, the same keywords for different things. So we decided to use this approach. And in this case, I have the very exact information that helped me to convert and translate this object to something that is semantically interoperable. We built a very simple Swagger editor version that can query our dictionaries. This is a GitHub page application. So when we add these specific custom fields referencing a vocabulary class such as person, the web interface dumps all the properties that you can associate with a given class. You can then use a subset of those properties. You can change the field name if you don't like or you want to localize the properties. But thanks to the mapping, it is always possible to generate and convert everything back to an object that has a very clear semantic meaning. This means that at the same time I can reference the right properties starting from an ontology and referencing code list. At development and mashup time, I can use that information to design integration tests between different API and being sure that the integration is semantically consistent, that I'm using the same vocabularies for countries. I can use the same currencies for what I'm developing. And for example, at runtime, I can even implement something like localization of information. I got the 3-letter country code. I dump somewhere the European vocabularies for country, and I have the localization of Italy in all the language of the European countries, in Bulgarian, in Romanian. I don't have to write it in my application. I can just source the one that I have in the European vocabulary for countries. And in API catalogs, I can make checks when people add API to catalogs. And I can check that the semantic of the API is consistent with one of the ecosystem I'm designing. Well, last slide. In Italy, we already have a set of vocabularies that you can find here. Sources are on GitHub. You can have a look at that. We are working to expand those vocabularies. They are developed with and in conjunction and aligned with the European Union vocabularies. There are even European Union vocabularies and authority tables that you can reach there. And we are now working on this national data catalog for semantic interoperability, where you will be able to find reusable vocabularies and ontology, because maybe you don't know anything about ontologies. You will be able to look, for example, for person or school, and you find all the vocabularies related to school or to people or to provinces of the various ecosystems that you have in the API world. You can share semantically interoperable schemas. So agencies will provide standardized schema that you can reuse if you have to interact with other public agencies. This is a work that we are going together even with other countries in the European Union, because one of the cornerstones of the European Union is to provide the same services to all the citizens of the Union. This means that countries should be able to exchange information and to limit all the conversion that are required to process this information. Clearly ensure that APIs have a current meaning, so you can upload your OpenAPI schemas in the catalog, and they will check if every field is semantically consistent. And then we hope to publish relevant code list about provinces, cities, kind of documents, and a lot of other information, not only in semantic format, just like Turtle, but even in OpenAPI and JSON schema. This means what we hope is that if you want to create a web form, for example, you can just source the OpenAPI schema and generate automatically forms so that agencies can directly gather information from citizens already formatted in a semantically consistent way. Well, I think I'm over. Thank you for your time. Thank you for listening. Hope you enjoyed it.
Thank you, Robbie. We have got 3 questions.
Okay.
You ready?
Yeah.
Yeah, okay. So the first one is, what happens when you have to use a specific domain vocabulary and you have to mix it with another vocabulary? How to disambiguate?
Well, in general, if you have to use different vocabularies, you have to create a work group with domain expert. And while in the public sector, generally you have laws and regulation. So with the semantic expert, you have to design a specific vocabulary with ties to other vocabulary. Then through tools just like Sparkle or semantic inference, you can be sure that those vocabulary are semantically consistent, but there is some human work that have to be done. In general, if there are very specific domains, the simplest thing to do is to say, okay, I use for the core data sets, name, surname, country of birth, the core national vocabulary, and then for other fields that are specific, for example, to revenue, income, a different vocabulary. So use different vocabularies, trying to align to the core one for the core data set.
Thank you. Second one is, which domains show the greatest progress in international standardization?
Which domain?
Show the greatest progress in international standardization.
Well, who made this question? Because
It could be also a remote
Okay.
team.
Which kind of domain? Well, there is a lot of work in the healthcare sector because there are specific standard, but even there it is not very easy because there are huge vocabularies as far as I know. I'm not an expert in the healthcare, and every group of countries usually specialize those specific domains. There is a very general vocabulary that is schema.org that tries to standardize things around the web and generally commerce, the commerce sector, but is very broad and may not be very specific if you have to convey information that are legally binding, that contain legally binding information. And there is the financial sector. The financial sector usually, to enable interoperability between financial institutions, banking and financial, I think they made a lot of progresses.
Great, thank you. The other question is, today, who are the main users of the National Data Catalog?
Well, today, the National Data Catalog for Semantic Interoperability, we deployed a minimum viable product, but we are still working on the final version. Currently, main users now are semantic world expert and public agency that have to create model specific domain. For example, the school sector, they have to model to be able to interoperate between different regions. How students are modeled, how schools are modeled, at least in Italy. There have been a lot of work for municipalities to standardize the services around cities, because we have roughly 8,000 cities in Italy, and until recently everybody produced service in a very different way. And one of our actions was to create a city website template. And to create this template for website template, every category of service, every category of the users of services produced by citizen, national registry services had to be categorized. So those were the main area of works that had progress. But still we need to work to identify and expand the national core of ontologies that have the goal to provide a base for all, horizontally, all ecosystem, environment, healthcare, finance, income. So there is still a lot of work to do to standardize horizontal spaces, because vertical spaces are actually well organized in a way or in another.
Okay, we have got other two questions,
Okay.
but we have got only 1 minute.
Okay.
So if you try to shrunk them, the
Right.
answers. Okay, so how much does it cost in terms of operation to integrate two software components in this standard way?
The point is, if you do it at design time, the cost is minimal, because it's in the design. You have to design your API, you have to check. So you have a little overhead in terms of design. In many cases, the problem is that who wrote API doesn't design it, just write code. But if you have to design, you check dictionaries, use them, and the overhead is very minimal.
Okay, just be quick. Is there a concept of extending models? For example, an employee is a person with additional fields.
Yes, it is, but if you're interested, I'm open to show you the current catalog. And yes, it's a graph. You can add nodes, relations. So
Thank you, Roberto.
thank you. And thanks to the organizer.